Hello everyone, welcome to MATLAB Helper's live webinar on neural network. I am Aditya Chaudhary, and in this webinar I'll walk you through how to enroll for the neural network course on our website, which I'll do at the end of the webinar. And then we shall majorly cover two topics. First is the data fitting, and second is the pattern recognition using MATLAB's inbuilt tool. So let's start. I'll share my screen. Okay, so it again says welcome to MATLAB Helper YouTube live webinar. So before starting, I have shared my screen and will explain how we will deliver this webinar. So I'll be writing on the screen, like on the blackboard, whenever it is necessary to, like if I want to add some points, I'll be writing over here. I'll write my name here, Aditya. And whenever I want to mark anything on my screen, I'll simply write on my screen. So this is the way I will be delivering this webinar. I'll also be using a magnifier which you can see at the bottom right. So you can see this is a magnifier. So I would suggest everyone to log on to their browsers in order to watch this session, because we'll be covering a lot of the part over MATLAB. So I'll close the magnifier for now. So this is MATLAB, and let us start with the first part of data fitting, wherein to start the application of neural networks, we have to type NN start in the command window. So this is one option of starting the neural network system toolbox. Another option is I'll simply first run this code and then start, and you can see the neural network start panel appears over here. So that's one way of opening neural network start panel. The other way is through apps section. Just go through the drop down section over here, and you will find the machine learning toolbox. Then you will find neural network fitting application over here. So just solve fitting problem using two-layer fit forward networks. I'll just click on this and it will take to neural network fitting application toolbox. So this is the neural network two-layer fed forward network with sigmoid hidden neurons and linear output network. So basically this is the neural network architecture consisting of input, hidden layer, output, the output layer and the output. So before starting with the neural network, what exactly is? So let us understand what are the advantages of neural networks. You guys can comment in the comment section right below so that even you can answer what the advantages of neural networks are. And I'll be watching those comments. Even if you have any queries regarding whatever I'm going to cover in this session, you can comment your queries right down, and our coordination team will get back to you. And even we will have a question answer session at the end of this seminar where I'll solve all your queries. So coming back to our question, what are advantages of neural network? So neural network basically has an ability to learn and model non-linear and complex relationships. So that's one point, and another point is it has better models as compared to the other network systems. The applications of neural network. Applications of neural network are again image processing, character recognition, forecasting. Now, you just imagine a condition where you have weather forecasting or you have financial forecastings, which are something like what will happen tomorrow? Will the market go ahead or will it doom? So that's the thing where forecasting is required, and neural network is the best tool for doing that. So it's basically used for financials, stocks for forecasting, predicting complex non-linear relationships, and so on. So let's continue with this part. This is the neural fitting panel, welcome panel. So we'll just click on next button over here. On clicking the next button, you can see this is a select data panel, which is the neural fitting or NF tool. So we have to give inputs and targets. So I'll just use my screen to explain this thing. We have to add the inputs in this place and we have to add the targets at this place. So this is when you are working on something and you have a data of say thousands of inputs and thousands of targets, and that is a point where you can train your entire neural network. But for this example, we'll be using the load example dataset, which is already inbuilt in MATLAB. So let's click on this load example dataset over here. So you can see this is the fitting dataset chooser. You have to select the data from here. And for this session, we'll be selecting the chemical dataset, which has this function and has 8 into 498 metrics defining inputs, and similarly it has targets 1 into 498. So we just have to import this data over here. By clicking on import, you can see the summary over here. The data has been imputed. 498 samples of 8 elements were chosen for input, and 498 samples of 1 element were chosen for chemical targets. So let's click on next. In this panel, this is the validation and test data panel. So we have to select percentage random, which randomly divides the 498 samples. So say over here we have training, which is 70%. We have validation, which is 15%. And we have testing, which is 15%. So what exactly are these training, validation and testing? Let us understand these things. Training basically, these are presented to the network during training and the network is adjusted according to this error. So we are selecting some 70% of the samples, which comes to 348 samples. Validation is something, these are used to measure network generalization and to halt training when generalization stops improving. So these are basically the validation samples, and in this case we are selecting it as 15%, and for testing we have 75 samples, which again are 15%. Testing are the ones, these have no effect on training and provide an independent measure of network performance during and after training. So let's move on. We'll be using this default values of 70%, 15%, and 15% in our neural fitting. So we'll be using default values. So I'll click next to proceed. Now this is the major part of network architecture where you have to set number of neurons in the fitting networks, hidden or the hidden layers. So basically, when we select hidden neurons, it's like we are selecting by default it's 10 neurons. So as you can see over here, there are 10 neurons over here. So there's a recommendation written over here, return to this panel and change the number of neurons if the network does not perform well after training. So these neurons by default are 10 and need to update, or we can add more neurons in order to get perfect values, or if the training does not go proper, you can edit these neurons after coming back to this panel again. Here you can see a link fitnet which will take you to the MATLAB documentation for defining this fitting neural network. I'm keeping the default value as 10 and let's proceed with the next panel. The next panel is the train network panel where you can see we have to choose a training algorithm over here. And there are three algorithms over here. One is Levenberg-Marquardt, next is Bayesian regularization, and the third one is scaled conjugate gradient. So I'll explain a few things about this algorithm. The first algorithm, Levin-Marquardt algorithm, is recommended for most of the problems, but for some noisy and small problems. So whenever we are working with small problems and have some small data, we'll be using this algorithm. The second algorithm is something you can which take a longer time but obtain better solution. So Bayesian regularization is the algorithm which takes a longer time, but it obtains a better solution as compared to the other two algorithms. And the third algorithm, which is the scaled conjugate gradient, is recommended for longer problems as it was gradient calculations, as it uses gradient calculations, which are more memory efficient than Jacobian calculations, which the other two algorithms like the Levenberg and the Bayesian use. So these two algorithms in the first use Jacobian calculations, whereas the third algorithm use a memory efficient algorithm called as gradient calculations. So depending upon our use, we'll be using the algorithm. For now, we'll be using the first algorithm, Levenberg-Marquardt, because we just have some 498 samples. And then you can see this algorithm typically requires more memory, but less time. So even they suggest that we use this algorithm over here. This training network panel keeps training, it happens like training multiple times will generate different results due to different initial conditions and sampling. So to train the network, we'll simply click on this train button over here, which says optimize network on inputs and targets. So I'll click on this button train over here and it says training network. You can see the results over here, training 348 samples. We have MSE, we have R, which we'll see in detail in the next panel. So I'll navigate to next panel directly. So this is our next panel, which again shows the network architecture, the algorithm used, which is the random training Levenberg-Marquardt algorithm, performance, which is the mean squared error, calculations, which are mixed calculations, epoch, it used 20 iterations, and we have this validation checks over here. So I'll explain a bit of this validation checks before proceeding. Also, we'll see all the plots which are given below, like the performance plot, the training state, error histogram, regression, and the fit plot, which is the most important in data fitting part. So for the validation checks, I was saying that there were 6 iterations in these cases. Like the training concluded, the training continued until the validation error failed to decrease for 6 iterations. So the validation stopped after 6 iterations, and that's why the number 6 over here. Now moving on to the plot section. If you guys have any queries, you can comment down in the comment section, and our coordination team will get back to you. Even I'll answer all your queries after the session. Right after this session, we'll be having a question answer part where we'll be solving all the doubts. So moving on to the plot section. The first section is the performance section or the performance plot. To open a plot window, I'll click on this performance and it says opening performance plot. So this is the performance plot. Actually, I'll close the mirror right now because it might create a lot of confusion, and I'll open this plot over here to have a better view. So this plot is against, this is a mean squared error plot against 20 epochs, which we already saw. And to explain this plot, let me use my pen. The training samples are in blue, which you can see the blue line over here. The validation sample are in green, so you can see the validation samples are in green, and the test samples are in red. Whereas this dotted line over here shows the best matching point. So you can see the title of this plot says best validation performance is at 3.8417 at epoch 14. You can see at epoch 14 the validation is complete and all the values till this data are perfect. So this is the point where best validation performance is obtained. So this is a place where you can find out the best validation points for all your 498 samples. So minimizing this window again. Next is the error histogram plot. I'll open the error histogram plot. The blue bars here represent training data. The green bars represent the validation data. And the red bars represent testing data. So the histogram can give you an indication of outliers, which are data points where the fit is significantly worse than the majority of data. In this case, you can see that while most errors falls between -5 to +5 range, you can see the most of the data are from this part to this part, which is -5 to 5 in the graph. There is a training point with an error of 17 and validation point with error of 12 and 13. The outliers are also visible on testing regression plot. The first corresponds to the point with a target of 50. So If the outliers are valid data points but are unlike the rest of the data, then the network is extrapolating for these points. You should collect more data that looks like the outlier points and retrain the network. So I hope this plot was clear to you guys. Now coming back to the applications of these things, before proceeding to regression plot, we'll discuss few applications, and I want you guys to comment down whichever application you know, so that even I can understand few things and I can explain in a better way. So for the application section, I said image processing, forecasting are the applications where you can, where financial forecasting, for financial forecasting, we use this neural networks. And why basically we need this data fitting is curve fitting is actually a process of constructing a curve or a mathematical function that has the best fit. So in this case, we are constructing a curve or a data of series of data points. We have a series of data points which we have loaded from the inbuilt GUI of MATLAB for this chemical example over here. So to best fit the data, we are using this tool called as data fitting. And that is what I'll show you in the last plot over here, which is fit. Before we proceed, I'd like to tell you these are again the links for documentation in MATLAB. So if you want to know more about the plot performance or how to plot this, you can simply click on this link over here and it will take you to the MathWorks website where the documentation regarding this performance plot is present. So moving on with the regression plot. So the system says it's opening the regression plot. So this is the regression plot. I'll close the magnifier and open this part. In the regression plot, basically you can see there's a 45-degree line in training, validation, and test. And there are the data points, like the small points you can see over here marked as data. And we have y equals to t as the best fit line or the perfect line. You can see this small line over here, which is the perfect line, the dotted line. And we have this 45-degree axis, and we have plotted all the dots over here. So the idea behind this is more the data is towards this 45-degree line, more the better it is. These are the outputs, which are the expected outputs plotted against the target, which were fed into the data set. So basically, these are all the 498 data points, or say 398 data points in training, because we had divided it into 70%, 15%, and 15%. So it had 398 data points, validation had 71 data points, and test had 71 samples. So basically, these all small dots are these samples which are plotted. And you can see most of them are plotted near the 45-degree line, which is again a good sign that our system has been trained. And if in case your data is mismatched or it's randomly over here, and all over the graph, then you have to retrain this entire system by either increasing the neurons or by increasing some another algorithm. So as I said earlier, for the perfect fit, the data should fall along a 45-degree line where the network outputs are equal to the inputs and targets. And there are three plots again for training, validation, test, and a combination of all of them as all the graphs. So these are all the data sets which we have imported into our workspace. So if you have any query regarding MATLAB or regarding what I'm explaining regarding neural networks, if you are not able to access anything, do comment down in the chat section below so that I can take up the queries and answer accordingly. Even we have the coordination team who will answer your queries, and I'll be answering all your queries regarding this session at the end of regarding this webinar at the end of the webinar, wherein we'll be having a question answer session. So moving on to the last and the very main part of the plot, part of data fitting is the fit plot. Now here it shows an error. The input data has more than one element. The function can only plot single input problem. So this is the problem where I wanted, for which I wanted to take the chemical example as compared to the other examples. Now for whenever you encounter this problem, it basically occurs due to the input having more elements than the function that actually can plot. So that's the reason why we take different algorithms. To remove this plot, you can either go back and train your entire system. That's you can simply go back and change the number over here, which is 10, to some another number to get the proper fit. So moving on further, we'll click on the next button over here. So this comes to the evaluate network, which gives us again three options. As you can see over here, the three options are train again, adjust network size, and import large data. So as I said, if you want to retrain the system, you can click on the first option, which is the train again option, or you can simply adjust the network size. That is, you can adjust the value of value 10. And if you want to work again with another larger data set, you can use the third option over here, which is the import larger data set. So if you are like dissatisfied with the network's performance, you have three options, which is train it again, increase the number of neurons, get a larger training data set. So if you are satisfied with the network performance, click next. Now this is the option where it gives you four deploying methods in order to proceed with your code. So this is called as the deploy solution panel, which is generate a deployable version of your trained neural network. What you can do is you have option of deploying the application directly in MATLAB, which is a generalized function. So you can click on this button over here, which will take you to MATLAB function. It will create a MATLAB function with matrix and cell array argument support. The next is the code generation, which will create a code similar to the first one without the matrix arguments. So there won't be any cell array support in this MATLAB function. The third one is the Simulink deployment. So If you click on this Simulink diagram, it will create a Simulink block of whatever simulation or whatever training we did to our data set, and you can simply use it for other data sets. Last is generating a graphic diagram of neural network. So this will create a network diagram, but we won't be creating any option right now, but because we'll be using a simple script rather than using all these functions. So to create a simple script out of it, simply click next, which will take you to save results panel, when you can generate MATLAB scripts, save results and generate diagram. So you can see the option over here called simple script, and then you have another option, advanced script. So advanced script is something with additional options and example codes. So we'll be going with the basic one for now. We'll be clicking on simple script. But yeah, before that, we'll also save the outputs. You can see save data to workspace. So we'll save these results over here. I'll click on save results, and in the workspace area, you'll see all these variables are added. These are the input variables, these are the target variables, and these are the result variables which got added just now. Now we can simply create a simple script by clicking on this button, simple script, and here is the script created by MATLAB itself. Wasn't that easy? Now you can see this portion has your inputs and targets which you selected from the preloaded or example values, but you can change this data set anytime because you have the code ready now and you can run the code at any moment of time. Moving on further, you have a create a fitting network option where you can see the hidden layer size is 10, which we selected the number of neurons as 10, and that's why it's written 10 over here. You can change this number if you want to retrain it, if you do not obtain best results. So moving on further, the next section, you have this division of data in training, validation, and testing. So as I've explained earlier what exactly this training, validation, and testing mean, and we had selected the values at 70%, 15%, and 15% for respective training, validation, and testing. So these values are getting reflected here, and you can change this value anytime when you have larger data sets, when you want to when you want to train more number of samples as compared to validation and testing samples. The last section is the plot section where you can plot the figures like we saw the performance plot, we saw the error histogram plot, and the regression plot. So this was regarding data fitting using neural networks. So before proceeding to pattern recognition, I would like to ask you guys what exactly pattern recognition is. You can comment down in the section below and I'll wait till you answer. So till then, I'll continue and I'll tell you a few applications of pattern recognition. But meanwhile, I'm expecting a few answers from you guys. So applications of pattern recognition are, say, speech recognition, you have traffic analysis and control. So imagine a situation, something like you are stuck in a traffic and you don't know where to proceed. You have four routes which take you to your destination and you have no idea on which route you can find less traffic. So how about using this pattern recognition at every intervals of time, or if we say we have some sensors on all the four roads, or we are tracking, we are doing an analysis of entire traffic, which will tell you by recognizing the entire pattern of that area which route to take. So that usually happens with you when you use Google Maps, right? So if you can see those red markings which shows that the traffic, there's a heavy traffic in that area. So it all depends upon the recognition. It basically tracks the live location or the GPS locations of others and feed it to the systems, some like the pattern recognition systems, and automatically detect that there's a congestion in that area. So pattern recognitions are used for either analysis purposes, be it like traffic analysis, control, then to classify the things. Now, say you have a bottle and you have a jar of water. So how will you classify based on, like, you have some 10,000 images of bottle and you have some 10,000 images of cups. So to distinguish both the things, you'll have to train the entire network in such a way that it will identify both the objects uniquely. So the technology which is useful for automatic detection of shapes, forms, and classification basically are like the pattern recognition technology. So let's start with the pattern recognition part. And this time we'll type nn start from the command window. Last time we had navigated to apps. We have selected the drop down section, and in the machine learning we had selected the net fitting part, which was where we were doing the data fitting portion. At this time we are doing the neural network pattern recognition. But before clicking here, I'll be using the command window just to show you a few things. I'll type nn start and hit enter. So this is the main neural network systems panel where you can see the getting started wizard over here. I'll just switch on the magnifier for you guys. So this is the getting started wizard over here. So each wizards help you solve different kind of problems. So we have seen the fitting app. We have seen, we'll be seeing a pattern recognition app in this session. And there are some links over here, NF tool, NPR tool. So these are the documentations on pattern recognition and fitting apps which are provided by MathWorks. So if you click on these links, you can directly see the documentation part. So clicking on the pattern recognition app portion, this is the first panel of pattern recognition part. So as it says, there's an introduction. In pattern recognition problems, you want a neural network to classify inputs into set of target categories. Now, in this app, we'll be taking an example which is mentioned over here. So, for example, recognize the vineyard that a particular bottle of wine came from. So you have some n number of wine bottles in front of you, and you want to classify them from which vineyard did this specific wine came from. So it is based on like all the categories. Say, for example, based on the chemical analysis, you have the classified tumor or beginning or malignant. So there are other parameters which are used to classify the system. So the neural network or the neural pattern recognition app will help you to sort this data accordingly. Here again, you can see a two-layer fed-forward network with a segment hidden and softmax output neuron. So we'll be setting again the number of neurons in this part. So I'll click on next button over here. And in this portion, again, you can see this is a select data or inputs and targets which which you have to fetch from your workspace. So, but we are going to use the load example data sets, which we also used for data fitting, but we'll be using some another example. This time of this wine vintage example we'll be using. So here you can see there are some 178 metrics of 13 types. So basically they had divided this 178 types of wines into 13 chemical combinations which are distinctly identified. So these are the names of 13 chemical combinations. So this is our input, and for our target, we have three vineyards. Say we have vineyard number 1, we have vineyard number 2, and we have vineyard number 3. So we have to classify, we have to understand from which vineyard this particular bottle of wine came from. So I'll import the data. And click on next button over here. So here comes the validation and test data window, wherein you have to select a percentage. For training, it's 70% of the data. For validation, you can use 15% of data, and testing, we are using 15% of data. These are the default values we are going to use. So you can, in this case, you can see there are 124 samples for training. You have 27 samples for validation, and for testing we have another 27 samples. So the explanation of these parts or the training, validation, testing is similar to what we did in data fitting. Training is like these are presented to the network during training, and network is adjusted according to its error. So these parts are the main samples which will train your entire system. Validation is the part used for general network or like for generalization, and to halt training when generalization stops improving. So for testing, again, as I've said, these have no effect on training and also provide an independent measure of network performance during and after training. So let's click on next button to move ahead. So here it asks for network architecture and number of neurons. So we'll be keeping 10 as the default value without changing it. You can see the network diagram over here. I'll click on next. So this is a place where you train the network. To train the network and to classify the inputs according to the target. So I'll click on this button train over here, which will train the samples, and we'll see the results. Now, since the result is getting generated, I would like you guys to comment down all your queries, which we'll take up at the end of the session. And if you have anything which you guys want me to repeat from both the data fitting or neural network, you can comment down that as well. So I'll be taking the question answers right after I finish this pattern recognition. You can comment all your queries regarding MATLAB, regarding what MATLAB helper is, regarding the courses, and regarding what we are doing in this session. So the training is complete in this part, and moving to the results section, you can see the results over here. But we'll be clicking on the next button to see the exact I'll just close the extra windows which we got during this training. So this is the training or neural network final panel, where you can see the neural network architecture over here, which we had designed earlier. You can see data division, you can see the training, you can see performance and calculations. Now, one thing you might have noticed is, which is different from data fitting, is that there was no option for selecting the algorithm. For this pattern recognition, we use the scaled conjugate gradient algorithm, which is very much similar to data fitting's third algorithm, which I explained earlier. So, do you guys remember this algorithm? It was scaled conjugate gradient algorithm, and which used the Jacobian calculations and not the memory efficient, which was memory efficient and used the gradient calculations and not the Jacobian calculations. So this is the part, or this is the training algorithm which we used. So again, we have these links for documentation. If you guys need any help in these algorithms, understanding these algorithms, you can simply click on these links. For the epoch section, you can see there are 38 iteration and valid checks. Again, the iteration, there were 6 iterations of validation, and after 6 iteration, it stopped. So next part is the plot section, where you can see again the performance plot. I'll simply open the performance plot. Now here you can see the best validation point has moved from point 3 or something in data fitting to this place over here. So this is our best validation performance point, which is at 0.05357 at epoch 32. 32 is over here. So this is our best point, or you can say best validation point. This plot is again plotted against, like it's the cross entropy versus the 38 epoch plot. And the blue line indicate the train or the training samples. Green line indicate the validation samples, and red line indicate the test samples. For pattern recognition, there's a major thing which we always see is the confusion plot over here. You can see the documentation on these links. So I'll show you the confusion plot, which is very exciting to see. So here you can see there are 4 outputs or the 4 plots. One is the training plot, that is the training confusion matrix over here. Next is the validation confusion matrix. This is the test confusion matrix and all confusion matrix together. So there is one thing which you might have noticed is all the green colored blocks are at the center, which was like at the 45 degrees in the data fitting. So all the best or all the best samples are gathered at these points in green blocks. The red blocks indicate errors. So if you can see in validation point, there's an error over here. So you can see there's one sample which was not validated into any of the vineyards. So we had 3 vineyards. These are the output classes. We have the vineyard number 1. We have vineyard number 2. And this is the third vineyard. So these training has successfully classified 40 samples into vineyard 1, 53 samples into vineyard 2, 31 samples into vineyard 3. So isn't that interesting? Depending upon those 13 parameters or 13 classes which we had defined earlier, it has classified all the samples into respective vineyards. There's only one validation error, so it sums up to 3.7% of the data, which is the error or which is marked in red. There's only one sample which was not classified or not validated into any of the wineries, and together, like the training, validation and test confusion gives you the final output. That's our all confusion matrix. So we had 59 samples in which came from winery 1, 70 samples which came from winery 2, and 48 samples which came from vineyard 3. So this is how you can see the pattern or the recognized pattern, and that's the reason why confusion plots are very important in pattern recognition. Last is the receiver operating characteristics, which is again easy. In this section, you can see while training system, you just have to remember the more these lines are towards this is towards the y-axis and this is towards the top, the more the better the results are. Consider if we have something like this and there's a square like this way. So this indicates that there's an error in your system and you need to retrain your entire system. So this is something called as the receiver operating characteristics, and it's true for all the three: training, validation, and test ROCs. And like we had only one sample which was not validated, you can see there's a very small distortion in this area, which indicates that the system might require something to retrain, or you need to change the neuron values. Moving back to the panel, you can change the plot intervals also, but we'll be keeping this as the default intervals. And I'll close this part. And if you guys have any difficulties or if you have not understood what I've explained in this plot sections, be it of receiver characteristic or confusion, you can comment down in the section below and ask me again so that I'll explain it again in a more better fashion. So comment down in the section below and I'll get back to all your queries at the end, or I'm also reading it right now, so you can comment down so that I can repeat the things as well. So proceeding on with our pattern recognition, I'll click on next. So here you see three options again as we saw in data fitting, which are train again, adjust network size, import larger data set. So if you want to train your system again, just go with train again, and if you want to change only your network size, click on adjust network size. And if you want to work with some larger data set, click on this data set. We'll proceed to next window. As I explained in the previous section of data fitting, here also you have four options for deploying, which are the application deployment, code generation, Simulink deployment, and graphics. But we just want a simple script, and that's the reason we'll be clicking on the next button, where you can save these results. So once I click on save results, you can see there will be addition of four results, that is the net1, info2, output2, error2 results to the workspace. To simply save the script, I'll click on this generate a script, simple script button over here. So once I click on the simple script, you can see the code is getting generated automatically. These wine inputs are the input data sets, and these wine targets are the target data sets. And this is the network size. These are the percentages which we selected: 50, 70, 15, and 15. This is the part where the test network happens, or this is the part when we click train button, this code, or if you see the documentation at that moment, you will see the documentation for this function. So to view the network, you can simply click on view net, and in the last part, you have figure like the plot the performance plot. We have the histogram plot, confusion plot, which is again very important, and the receiver operation characteristics plot. So we are done with pattern recognition part also, and if you have any queries, you can comment down so that we can take those things in the question answer session. But before that, I'll like you to take you to the MATLAB Helper website. So you can just log on to matlabhelper.com, where you can see these courses, you can learn them at your pace. So I'll just navigate to courses. So clicking on courses, we have currently 5 courses live on our website: Basic MATLAB, Digital Simulink, Neural Networks, Numerical Methods, and Basic Simulink. So if you are a self-learner and want to learn these things, you can visit our website matlabhelper.com/courses. I'll just show you whichever part I explained. So clicking on neural networks course and clicking study now will take you to the course where you'll have to enroll yourself. So this is the course page which shows how to access a course on MATLAB Helper. I'll just walk you through all these things in the later part of the session. So let's take this course and enroll ourselves on these courses. Let me log in with my credentials. So this is the course content. We have introduction to neural network, we have data fitting, time series neural network, and pattern recognition. And in this seminar, we have covered data fitting neural networks and pattern recognition neural networks. So if you have any queries regarding this session, you can comment down and I'll get back to you in the next session, next part, which is the question answer session. So just clicking on data fitting neural networks, you'll find the course which is made by our experts as well as verified by our experts, and it will give an in-depth knowledge of what you want to learn. So it has all the steps along with screenshots. You can navigate to the entire course, complete the course, and earn a certificate for yourself. So once you complete all the lessons and all the topics, we also do have assignments and quizzes at the end of every topic. So once you complete all those things, you can earn a certificate on neural networks from MATLAB Helper. So I'll just tell you how quiz works. Quiz is it's like a very simple quiz. So here are some rules to complete the quiz in given time. Every question carries 1 mark and you need to score a minimum of 80% to pass the quiz. So let's start the quiz and guess the first question. So I'm just showing you guys how to answer. So it's like this is the first question I'll randomly answer. You can check the answer and it says that your answer is wrong. So you can just proceed and you have another question. So in the similar fashion, you can complete all the courses. You can see the course navigation on right side panel and complete all the courses to earn a certificate of yourself. Let us see the pattern recognition lesson. This is the pattern recognition part which I covered in this session. So I hope you guys enjoyed this live webinar, and if you guys have any queries, you can contact us through our course@matlabhelper.com. Like you can email us all your queries, and if you're enrolling our courses, I'm sure that you won't be having any queries because all the materials is explained in a very structured manner. We'll be also having a live session in by the end of this month on Arduino, when we'll be using all the hardwares to demonstrate how to interface Arduino with MATLAB, and I hope that would be more interesting. I wish you guys also fill the feedback form, which is given in the link description below. We would like to know how you felt about this session, and if you have any queries, you can email us regarding the courses. You can email us at course@matlabhelper.com. And if you have any assignment or if you have any work which you're stuck with and you don't know how to proceed, you can email us or your requirements, and we also provide expert services for students as well as professionals. So hope you guys enjoyed this session of 1 hour. Don't forget to fill the feedback form. The link for the feedback form is given in the description. And stay updated for the live webinar, which we'll be conducting at the end of this month, wherein we'll be showing how to interface Arduino using MATLAB. So I'm pretty sure you all will be interested for that. So have a great day. Bye-bye.